Well, now let's graph the solution to a linear inequality using what is called the test point method. Here is our inequality. Notice that if I replace the greater than or equal with an equal sign, we simply get a straight line. So, first we replace the inequality with an equal sign and graph the line. Now here's an important thing to remember. Oops, that should say solid. Use a solid line if the equal sign is included in the inequality. Use a solid line for greater than or equal or less than or equal, and we use a dotted line or a dashed line if it's a strict inequality, strictly greater than or strictly less than. So we have the greater than or equal, so we're going to use a solid line. So when we do the replacement, we get 3x minus 2y equals 6, and I'll make a note, use solid line to graph the line. Well, rather than writing this in slope-intercept form and getting the y-intercept and then using the slope, let's see if we can, just in our heads, come up with 2 points, 2 ordered pairs x, y, that would satisfy this equation. I can think of an easy way to do it. For example, 2 points. I'm going to set x equal to 0, and then I'm going to set y equal to 0, and see what the other corresponding value would be. Well, if x is a 0, this 3x term goes away, and we would have negative 2 times y equals 6. So dividing both sides by negative 2, we would get 6 over negative 2, which is negative 3. Okay, in this case, I set y equal to 0. Well, if y is equal to 0, then this term goes away, and we have 3x equals 6, which means x would equal 2. Because remember, if you have two, let me rephrase that. To graph a line, all you need is to have 2 ordered pairs or 2 points that are on the line, and you plot them and draw the line through. So 0, negative 3 puts us right here. And then the other point is 2, 0. So if I want to draw that line, this looks similar to the previous line we had. That's the line, and I used a solid line to graph it. Now, the test point method says that we need to just choose a point on the upper half plane or on the lower half plane, either way, and we see if that point is satisfied by this inequality. If it is, whichever half plane you're in, you shade that one. So a nice, easy point to choose in this case is the origin. Let's choose as our test point 0, 0. And I'm going to write this inequality up here, only I'm going to replace x and y with 0. 3 times 0 minus 2 times 0 greater than or equal to 6, and that statement is either true or false. Let's see. 0 minus 0. Is 0 greater than or equal to 6? No, it is not. So 0, 0 is in the upper half plane. Since this did not satisfy the linear inequality plugging in a 0, 0, I do not shade this region. Instead, I shade this region, the lower half plane. Just like that. And if we would have chosen a point down here, say 0, negative 5, this point, it would have worked. It would have satisfied this inequality, and we would have got the positive result, and we shade the lower half plane. Just as a reminder, every time we have a linear inequality, we're going to shade a half plane. So we need to first graph a line and then figure out, one method is using the test point method, whether we shade the lower half plane or the upper half plane. Okay, an alternative method And this is the one I typically prefer for graphing a linear inequality. So, after we plot the line, we can do this. Now, first recall that in an ordered pair, xy that's on a line, the value of y is the height of the function at that given x value. So what I do is write the linear inequality in slope-intercept form. So it either looks like this, 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 or this. And notice, if you have y greater than or equal mx plus b, or y strictly greater mx plus b, then which half plane do we shade, upper or lower? Well, y is the height, and it's greater than or equal. In this case, it's greater than. If the height is greater than the line, then you shade the upper half plane. And likewise, if you get y, the height of the function, being less than or equal mx plus b, or strictly less than mx plus b, then you shade the lower half plane.